Hi class, it's Bill here with the final video, I believe, in the series on databases, tables, and indexes, the SQL that creates these. We might need one more video for the indexing depending, but for the moment let's get back to where we were. We had completed the SQL that created the database and the tables and worked with the table level constraints, including primary keys, especially composite ones, and foreign keys. All of them have to be created that way. And now we're down to looking at some other things, like how do we do the proof of concept? How can we add some sample data so we can convince ourselves that things are kind of as they should be? So let's jump back down to where we were there, and that is we wanted to create sample data. So if we want to add some customers, we want to add some pets, and then we want to add some linking data. Now the first part is pretty easy. Let's bring our notepad back. If we want to create customers, we know that we can do that pretty easily. We can say insert customer, and then we can simply list the values, right? We can say values, and we can just list some data. We can make them up. So really, like we can just say, customer number one, or we could say default, and then we can make up the customer name. Remember that if we're using the form of the command that does not require the command of the column list, we must go in the order of the database. So next come customer name. So, John, and then last name. Oh, actually, it's both John Jones, and then the customer phone number 206 555 1345, whatever, and then the customer balance. We could say default, remember, because we have set a default, or we could put one. So that's easy enough for us to do, right? And we could add multiple rows that way. So notice that both customer and pet are going to be very easy in that regard because the tables are kind of independent. They don't have any foreign keys in them. So therefore, those are pretty easy to do. And in fact, those are the ones we have to do first because we can't add foreign key data until there is corresponding primary key data. So that's easy. As you can see, it would be very easy for us to add this data. Now the other column is going to be a little bit more problematic, right? Because in that one, let's go back, notice that in this one we have the customer pet needs the ID, the cust ID, pet ID, and adoption date. So how would we do that, right? So let's just write that down. Customer pet, just for fun, it was just to remind ourselves, it was the cust ID, pet ID, and then adoption date. Make sure I got that right. Cust ID, pet ID, and adoption date. Right. So if we want to do that, how are we going to insert rows there? Now, one of the things that I've done over here, you might notice, is I've actually, rather than put defaults, I've actually put in numbers, right? And that makes it easier for me to go do this because when generating the linking data, there is no automatic way for me to generate this data. If you try to do it programmatically or by a cross join or something weird, it just doesn't make sense. So if you want to generate realistic linking table data, you just have to link it, right? You have to figure it out. And ideally, it would illustrate all of the flexibility of your database. So, for instance, in our case, we could say, well, Duke gets adopted and then gets returned, so it gets adopted by somebody else. So you want to kind of look at the relationships and kind of make some data that seems right. But the only way to really do that is to simply go through and figure it out. So let's say, for our purposes, just for fun, let's say that we're going to do some quote pseudocode here, right? So let's say that Judd adopts Fluffy, or actually Lucky, right? Lucky on, and then make up a date, right? So we could simply say maybe they got adopted and it was like today's, let's say 7/30, 2019, right? So maybe that adoption happened that date. And so then maybe, let's see who else is going to adopt. Maybe Betty adopts Fluffy on 8/1/19, 8/2/19, whatever, make up some data. So that's the way you have to go through this. You don't have any magic way to put this data together, and you just have to kind of go through. So once you do that, then we understand how to do this by coming up here and saying, okay, how do we record Jed adopts Lucky? Well, Jed is customer number 1, Lucky is pet number 2, and then the adoption date 2019-07/30, right? Then we can put a comma, and then we can go to the next one. Betty adopts Fluffy. Betty's customer 3, Fluffy's pet 1, and the date 2019-08/02. right? So the only good way to generate this data is to think about it. And again, a good thing to illustrate here, if the database accepts it, which it does here, is one pet gets returned and readopted. So there's not a return date, but you could have the same pet adopted again. So, but there's really no magical way to do this stuff. You can do things like saying 1 and 1, 2 and 2, 3 to 3, but it ends up looking kind of weird. And in our case, some customers haven't adopted, some pets don't get adopted. So really, that's kind of the way to do this, right? Is to go through and figure out how you want to put the data together. If you're getting data from the internet, by the way, this gets a little troublesome, right? Because figuring out how to construct this linking data becomes very interesting and sometimes problematic, and that's where you may want to reach for Excel or some other tool to help you pull that data apart and make the linking data. So here is a synopsis of how maybe all of this data might go, right? So we have different people adopting different pets, and that would be a full range of sample data. So in this case, again, putting these numbers here actually makes life a lot easier when it gets down to doing this, right? If you had just said default, you might be able to go back and say 1, 2, 3, 1, 2, 3. You can still go decode it, but your eye just has a lot more work to do. So hard coding these things for sample data, and you know the tables are empty because you just created them. So that actually makes life a little bit easier. The next thing we might want to do is do a sample query. The sample query doesn't prove that everything's perfect, but it proves at least that you've created data that is relatable, right? You can actually have the primary key, foreign key data that makes sense so that you can do queries. It doesn't prove that the schema is right, but it proves that the data is present for the join. So in this case, if we do an outer join, we can make sure that we have all pets listed, right? So in this case, we do outer joins and then continue with our left outer joining all the way through. So we see, for instance, Duke is not adopted, right? Duke has not been adopted. And these are the adoptions that have taken place. And notice if there are customers who've done no adoptions, they don't come out here, or they don't show up here because we're doing a left join with pet as our first main focus table. So that's a little bit about how you can generate sample data and do sample queries to kind of flesh out the proof of concept and show a client or show somebody what you've got in mind and that your database design seems to kind of hold together. The last thing we want to talk about quickly is index operations, and I'm going to kind of touch on that lightly here. The basic idea here of an index, we've talked about before, an index is generally to make things faster. Indexing makes it possible to jump in and find things extremely quickly, which means that both searching and sorting happen very, very quickly. The main idea is that we want our primary keys to be searchable very quickly because with foreign keys, it's got to match them, right? It's got to match foreign keys to primary keys. It has to do that really quickly or all of your joins are going to be slower than they need to be. So an index, what it technically does is whatever column you're indexing, like in this case the student number, it has to make a separate storage space and record all of those same numbers. Notice all of these are actually duplicated in the index. And then it also has to remember where that thing lives in this list. So the general idea here is it's, this row right here happens to end up in the index down here, right? Because the way that it is sorted, this is actually 1, 2, 3, fourth in the list, right? So it's fourth numerically or alphabetically, either one, but it's at row 1 in the database. So it uses the same data here, but it rearranges them because you'll notice if these things are in sequential order, you can now do binary searching for it, right? You can easily say, cut the thing in half, see if it's there. So for instance, if we're looking for 60023, we can say cut the thing in half, which is either this row or this row. That's too low. Cut the thing in, or cut the thing in half again. Maybe that's this row. So you can sort of narrow down half the list like you do when you say guess a number between 1 and 100, right? The first guess is always 50. So you can do binary searching on this thing. You can do lookups. You don't have to do sorting because sorting is just Here's the first one, go to row 3 to pick it up, and finding the row is easy, right? Jumping down in memory to find row 3 takes no time in particular. So if you have this index, you can do both automatic sorting and also searching that are extremely quick. So that's conceptually what an index does. Now, there is overhead, right? There is space overhead because every column that you index has to have a whole separate thing, right? All of those numbers get repeated. And so there is space overhead in restoring that plus the lookup data. And there's also updates. So if you add a new number here, it's got to go figure out what to do with that over here. It's got to go add that data, or if you delete something here, it has to delete this data. So there is a little bit of overhead in working with an index. The general recommendation here is don't do it unless you know there's a problem. SQL will automatically create an index for primary keys. Usually that's enough, so don't mess with it. Don't just go adding indexes all over the place because that's going to start slowing things down unnecessarily. The thing that I would recommend is if you know that there's a problem, then you can go add another index. Here's a great example. Somebody says from the support group comes to you and says, you know what, when a customer calls in and they give me their customer number, I can find them super quick with a search. But if they don't know their customer number and I have to look them up by phone number, that takes a lot longer. And we do that a lot. We type in phone numbers a lot. So how can we make that faster? And you go, okay, I know what to do. I'm just going to go add an index on the phone. That means, yes, it takes up extra space. Yes, there's going to be a little overhead with adding, editing, and deleting. But the customer support folks are going to be able to find customers virtually instantly, and even if the database gets really big and there's a lot of rows, it'll still be just about instant, right? So I would recommend don't try to just sprinkle these around and go try to index all over the place. Just don't do it. If there's a problem, fix it by adding an index. Now, what's the SQL that creates these things? It's really simple. You say create index, right? Now, if you can also say create unique index. Notice that an index by itself does not force uniqueness. The ones that are done for a primary key, yes, those are going to be unique, but otherwise you can choose. You can either create an index that supports only unique numbers or an index that supports duplicates, right? So it's your choice. You give it a name. You say which table it's going to be on, and then in parentheses, as you would expect, you can put a column or multiple columns, and you can do ascending or descending if you want to do that. Otherwise, it's going to default to ascending, of course. So for instance, if we knew we were going to index that by customer phone, we could say create index, name it, and then on the customer table, and then in parentheses, the customer phone column. So creating an index is super simple, but again, don't do it unless you see performance problems. How do you get rid of an index? Super easy. Drop index, you give it the name, and then you tell it the name of the table. So for instance, drop index, here's the name of the database object, and then that's the table that it's associated with. So indexes, the concept is a little bit harder maybe to wrap your brain around, but just know they make things faster. They make searching and sorting super fast, but there is overhead. So wrapping things up, if you want to find some more references on some of the auto increment stuff, the show statements that are possible are all there. Also, we're not covering in this class some things that you may be interested in. For instance, character sets. Are you going to store the data in Latin character sets or Unicode, and what are all of those and how much space does it take up? Great topics, but we're not going to talk about it here. Look it up in your book or online. We're not talking about collations, which are different ways to sort within character sets, which can be interesting. And there's also different storage engines. How is the data physically going to be stored? What is the technology that's going to be used to store your data on disk? How are the indexes going to be created? Those sorts of things are options that you can look into if you want to. So you're not responsible for any of that for this class, but it certainly is an interesting topic that you may want to look into. Next, that'll be it for here. So if you have questions, you can certainly leave them in the comments here. Or if you're in class, of course, you can bring those to class with you or send them an email or in a discussion forum. So thanks for watching this video series. Hopefully it's been helpful in getting this stuff figured out. And we'll see you another time in another video lesson.